Let's do one more example to make sure we know how to find the equation of the plane tangent to a graph. So we have this graph, xy squared equals 10 over z cubed, and we want to find the tangent plane at the point 5 square root of 2, 1. So now remember, the first thing we need to do is to make it so that this is equal to a constant. And this is no good for us. So we have xy squared equals 10 over z cubed. So what we're going to do is we're going to multiply both sides of the equation by z cubed. That makes it so xy squared z cubed equals 10. Well, this works, right? Because here's my function w and here's a constant. They don't always have to be equal to 0. I mean, 0 works as a constant, but so does 10. So that's fine. All right, and I already have my point P. You'll notice point P was given, and this time I don't even have to substitute to know my z value. It was given in the problem. So even easier. So let's find the normal vector. That would be the gradient of w. All right, so we take the derivative with respect to x. Oh, actually, let me write it this way. Wx, wy, wz. Okay. So if x is the only variable and these other things are constant, then y squared z cubed would be the derivative. Now if y is the only variable, you'd bring the 2 down. So it'd be 2xy z cubed, and then 3xy squared z squared. There's your gradient. Now this is the gradient at any point. But of course, that's not so useful for us. We want the gradient at, or the normal vector, at point P, which was 5 square root of 2, 1. Okay, so then to find that, we find the gradient, gradient at 5 square root of 2, 1. So we're just going to substitute. So square root of 2 squared times 1 cubed, 2 times 5 times the square root of 2 times 1 cubed, and then 3 times 5 times square root of 2 squared times 1 squared. All right, so this is 2. This is 10 times the square root of 2. And then this is 15 times 2, which would be 30. All right, there's our gradient. So now for the tangent plane, it would be 2 times x minus 5 plus 10 square root of 2 times y minus the square root of 2 plus 30 z minus 1 equals 0. Now, you'll notice that this is set equal to 0. So one thing you can do, and sometimes we do, is to divide everything. So if you look that this coefficient's 2, this is 10 square root of 2, and this is 30. So we could actually factor out a 2 if you want and make it 1 times x minus 5 plus 5 square root of 2, y minus the square root of 2, plus 15 times z minus 1. And 0 divided by 2 would still be 0. So in other words, we're just dividing everything by 2 because we can. It doesn't make it any different. It's still the same answer. It would still be the same plane. It just, for whatever reason, sometimes people like to simplify it a little bit and make the numbers a little smaller, which is fine. And I realized I forgot to show you that I did these in Maple. So if this was example 1 right here. So I graphed the surface, I graphed the plane, and then I graphed the point. And there you can see the points in red. I do that by making symbol equals box in here. And you can see that indeed that plane is touching at that point, right, as tangent. The one we just did is a little bit lower. There we go. So it's right here. So the aqua bit is the surface. There's the point right there. And the plane of tangency is right there. You can see it's just tangent at that spot. So that's a way you can check yourself in Maple, right? By graphing the surface, graphing the plane, and then graphing the point.